Good afternoon, ladies and gentlemen of Job 2 Honors. We're going to be starting today on section 10.3, which is solving rational equations. And then the essential question at the top, what methods are there for solving rational equations? And there are two main methods we've talked about, or that we will talk about, and have applied in some way to the other types of equations we've solved. So I give it over to the audience if you can tell me what you think these methods might be. Solving by factoring, okay? Now factoring is a technique that we could use depending on the type of equation that we're solving. And in fact, factoring I would call like a sub method. Like a tool within the method. So that's not going to over. So that's good for you to think of it though. What else? What are the major two methods, we'll call them? Any ideas? We've used these for other types of equations. Okay, X method again, that's like a factoring, that's like a subset of the factoring family of methods for solving quadratic equations, right?
There's one of them I remember, but I don't remember what we called it. Like, I remember how to do it. What is that group factoring you're talking about?
That'd be a technique of factoring, factoring by grouping. We did talk about that when we talked about factoring. I'm glad you remember that.
Can you give us a hint?
Well, one of the things is something we already did today that I've demonstrated up here, which was what?
Graphing.
Graphing. So graphing is what I call our method number one, and you can decide for yourself if that's if there's anything to that. And what would be the second method of solving equations? Maybe that wouldn't involve graphing. What would that be?
Pen and paper.
Pardon me?
Pen and paper.
A pen and paper, right? And what we'll do, what it is basically would be like solving for your unknown with just pen and paper, right? So what we do is we call this second method, we call this algebraically. And algebraically is just really manipulating the algebraic symbols to isolate an unknown variable, which when you find what it is, it's an unknown and not a variable, right? And I had a student in second period today, Rindy, who also offered a guess and check. Well, guess and check is really, it's not really one of your more traditional methods, but you actually could use it, right? Guess and check, and that's in some way you could call that like maybe algebraically. Algebraically. I'm missing a letter. Yeah, I'm missing a letter here. It didn't look right. Is there anybody here who has trouble spelling? Like spelling is not your strongest thing? So a couple of you. See what happens? So what happens is that most people are pretty visual, right? So I looked at that and I realized what? It didn't look right. So I was able to correct my spelling that way. But if you're really a strong auditory learner, you could have trouble spelling. And so what it is, you keep like the verbal in your head more. And what happens is those people are more phonetic spellers. So you'll spell it phonetically, because it's not going to look wrong to you so much, but the sound will be right. That's what my dad was, and my daughter's that way too. Okay, now graphing, the technique of graphing, have we used that technique in all the other types of equations we've solved? Yeah, so this is really a broad category of solving. In fact, we could take an equation like this, that's not a rational equation, and we could solve this by graphing. Okay, and even though, how would this, do you think this would be an easy equation to solve without graphing?
Yeah. Yeah, because you just have to square both sides and it looks funky.
Well, yeah, but the problem is when you square both sides, is you're gonna have like, well, we can go, I'll show you a solution set how it's done. I got it on paper. If you want to see it on paper, I have the solution to it on paper. But graphing, it's a heck of a lot easier. And if you have a calculator in hand, graphing is sometimes real easy compared to algebraically. So we're going to start out by exploring, talking about solving rational equations graphically. So to solve a rational equation, x over x minus 3 by graphing, says first identify any excluded values. So in this equation, x over x minus 3 equals 2, what's going to be our excluded value? So it'll be 3. And the way they have it, they said solve x minus 3 equals 0, and I like to go like this instead. I like to put x minus 3 cannot equal 0. So x cannot equal 3. And then it says, so 3 is an excluded value. Rewrite the equation with 0 on one side. So how do you solve this equation here for 0 on one side?
Over x minus 3 minus 2.
Minus 2. So we can rewrite this equation with everything besides 0 on one side. And so this becomes what we use for graphing. And then we come over here to the next thing, and they give us a table. So you have this table, graph the left side of the equation as a function. So that the left side is going to be x over x minus 3 minus 2. And if you plug these in, and I'm going to do this real fast, you get, if you plug in 0, you get 0 minus 2 or negative 2. So the point that we get here is 0, negative 2, which is going to show up right here. Okay? And then if we plug in 1, we get 1 over 1 minus 2. So that's going to be 1 minus 3, excuse me. So that's going to be negative 1/2 minus 2, which is negative 2.5. So negative 2.5 will go here. So here we have 1 comma negative 2.5. Okay, next if we try 2, if we have 2 over 2 minus 3 minus 2, we get negative 4. So we have negative 4, so we get 2 comma negative 4 as that. So I'm going to go ahead and switch the colors now to red. And 4, if we plug in 4, we get 4, that's purple actually, over 4 minus 3 minus 2. So that's going to be 4 minus 2 equals 2. So here we get 4, 2. And if we plug in 5, we get 5 over 5 minus 3 minus 2. So we get is 5/2 minus 2, which is going to be 1/2. So that's 1/2. So we get right here, we'll call this 5, comma 0.5. And the last one, if we plug in 9, over 9 minus 3 minus 2, what we get is we get 3/2 minus 2, which is going to be negative 1/2. And so that's going to be 9 comma negative 1/2. And I know I went pretty fast in the simplification and all that, but that's what you're going to get. So over here, we're going to plot these points. So we have this one right here, 4, 2. So that'll go right here. We have 5.5. So 5.5 is going to go about right here. And finally we have 9, negative 1/2, which is going to go about right here. And then for this other side, we have 0, negative 2. I already plotted that. And then we have 1, negative 2.5. So 1, negative 2.5 is about right here. And then we have finally 2, negative 4. So 2, negative 4 goes right here. And I don't know clear it is to you now, but what you have is you have your excluded value is 3, right? So this is going to be your vertical asymptote. Vertical asymptote is going to be x equals 3. And your horizontal asymptote is going to be probably -1. Yeah, probably -1. But what they're asking here, it says, so we graphed this, and I graphed the left side of the equation. So the left side of the equation looks like this. And then over here it looks like this. And then they say, identify any x-intercepts of the graph. There is an x-intercept at where?
1.
Okay, look along the x-axis. Where is the x-intercept found?
Looks like 5.
5 or so? Okay, let's go ahead and look at, I want to go ahead and graph that in the calculator here. Oops, let me escape, quit. Okay, there we go. So what we have here is, let me clear off here. We have x over x minus 3 and then minus 2 will go right here. So this is what it looks like. And so where do you see the x-intercept here? Looks like 6. Let's go to the table view to be sure. And there we go. All right. But you can see all the other values. See, all these other values were the ones that we entered, right?
Is that an error on 3 because that's the excluded value?
That is, yeah. Because what can you not do in math or in algebra? You cannot divide by 0. So that's why we have an error message there. So basically the computer just, the calculator just says, oops, does not compute, undefined. So it says, what is the solution? The solution is going to be x equals 6. And sometimes you could say there's an x-intercept at the point 6, 0. And so that's just the solving by graphing method. And I like the way the book does it here, because a lot of times you'll see the books, what they'll do is they'll, instead of doing it this way, instead of solving the equation for 0, this is how they'll do it. I'll show you how they do it. They did it the way I like them to do it. Delete, delete. But this is the way you see a lot of them do it. They'll put them like this, and then they'll find the intersection point. But when you subtract 2, you bring it right down to the x-axis. That's solved by graphing, and it's more a universal method. So what's the advantage of having to look along the x-axis instead of looking elsewhere? It's simpler. You know where to look, right?
Yeah.
You know you're just looking at the x-axis, and to me, that simplifies things. I'm glad your book did it that way. I commend them for that. Now, next thing we're going to do is we're going to talk about identifying the LCD. And it says LCD of 2 rational expressions. And what does LCD mean? Well, it means least common denominator. That's what it means. So let's go ahead and quickly find some LCDs, and we'll solve an equation too. So what it is, you take your 2 denominators and you say factor your denominator. So how do you have 8x minus 24 factored? X minus 3. And for this other one, we have, what is that going to be? And what happens, your least common denominator is going to be what? Well, it's going to be a combination of these things right here. So you're going to have 8 times 10 times x minus 3. But do we have to take x minus 3 twice? No, we don't. So it's going to be 80 times x minus 3. And what we're trying to do with least common denominators is get a denominator that when we multiply the expression by, like if we said this is equal and make this equation, we would be able, by multiplying by this, to cancel out everything in each denominator. So we're trying to develop kind of a prerequisite to developing the technique to canceling out denominators. And will canceling out denominators help us to solve rational equations? Yeah, it will. So let's look at this next one here. The next one here, we got 15x plus 60. What's going to be the factored form of this?
15 x minus x plus 4.
15x plus 4. And over here, we have x squared plus 9x plus 20. What is that going to be?
X plus 4, x plus 5.
X plus 4 and x plus 5. And so what's going to be our least common denominator for this equation? Okay, x plus 4 is part of it, but what else? The 15, right? So 15, and we have x plus 4, and what else? X plus 5. So if we multiply this equation by this thing here, we're going to have everything cleared out of the denominator, which is going to make our life easier.
So it would just be all numbers?
Yeah, it would be, but it'd be like you'll have numbers and x's and x squareds on top, possibly. Sometimes you have just numbers and x's. Okay, solving equations algebraically. Now it shows how to solve them. Gives example. So I'm just going to do this one thing here to solve this first one. Your turn. Solve each rational equation algebraically. We have 8 over x plus 3 times x plus 1 over x plus 6. What's going to be our LCD for this? X plus 6. That's going to be our least common denominator. So this is what we're going to multiply through by. So what we do is we're going to multiply this whole equation by x, only x plus 3, x plus 6. And we do that, we get 8 over x plus 3, and we multiply that by x plus 3, x plus 6. And on the right side here, we have x plus 1 over x plus 6, and what do we multiply that by? Same thing, golden rule of algebra. X plus 3, x plus 6, and we parenthesize everything here. Okay, and so this will cancel out here, and what cancels out here? This. So we have left is 8 times x plus 6, and on the right side we have x plus 1, x plus 3. And we go ahead and multiply all these together. On the left side we get 8x plus 48. And on the right side we get x squared. And that's going to be x plus 3x. That'll be plus 4x and plus 3. And then solving for 0 on one side, right? That's the technique. And so if we remember, Ben said a little while ago, he said as a way of solving equations, factoring. Well, it's going to be a technique within algebraically, because we have 0 is equal to x squared minus 4x minus 45, and what's that going to be? We're going to have a plus minus because we got this. So what adds up to negative, what multiplied is negative 45, but added together is
-9, +5.
negative 9, positive 5. Let's try that. So negative 9, positive 5. So yeah, that's right. So Gabby's right. So we have x is equal to negative 5, and x is equal to 9, and those are the solutions of that. And then what you do is, last thing you do is you try to see if any of these happens to be an excluded value, in which case you know that's an extraneous solution. But that's it. We're going to be working on exercises like that tomorrow. Thank you, class. We will see you tomorrow.